Okay, guys, so we are back over here again, and I hope now my screen is visible to you. Okay, so what we were telling about, we will just for today's session, what we will do, we'll just go to the virtual part of the Arduinos that we use, and we're going to use the software Tinkercad right over here. Okay, so for using Tinkercad, what we're going to do, we're gonna just go to the circuits. We're gonna log in first. I'm already logged in over here. So we're gonna go to the circuits and then we will build our own circuits. So we'll go to the official Tinkercad over here. We'll go to the circuits and we'll write over here. We'll write create new circuit. Okay, when we just write a create new circuit, when we click on it, just like this interface you will find over here. Now, before going in touch to this interface, I would like to know that are you a little bit known to Arduino programming? Just let me know in the comment section. Are you a little bit known to Arduino programming? Yes or no? Just let me know with the answer. Okay, I got it. So you don't know means a couple of things of Arduino programming. So let me tell you with this basics. So see, first of all, we'll just go with the Arduino board. Okay, so this is an Arduino board that we are getting over here. Right, yeah. So you can see clearly this is an Arduino board, and this is the interface that when we will start simulating it, means when we will be running it, this point, this is the connection where it will be getting connected to this. Now I will just use a tool to make you understand. Now you can see these are the digital pins as we have already discussed. Now this is the analog pins. These are the voltages. This is the ground, and over here we have one more ground. So we're going to use these things to connect and program our codes. So the first programming that we're going to do is uh, blinking an LED. Okay, so first of all, we need to know how to connect an LED. So this is our board, and we're gonna connect an LED. So we're gonna search LED right over here. So we got some LED. So one LED will take. Now this is a cathode, this is an anode. Now cathode is the negative part of the LED, and anode is the positive part of the LED. So we'll connect the cathode to the ground, okay, and anode to 5 volt. Now what happens when we connect cathode to ground and anode to 5 volt, the LED will glow. So let us taste if it is working. So we'll just start the simulation and we'll just see, yeah, the LED is glowing. Now there is a bursting option. Now what is the bursting? Current through the LED is 483 milliampere while absolute maximum is 20 milliampere. Now why this error is coming over here? It is telling that the LED will glow, that's not an issue, but the current flowing through the LED is too high to just let the LED glow smoothly. Okay, so what we're gonna do, we're gonna add a resistor. Okay, without directly adding this, what we're gonna do, we're gonna add a resistor. We'll just delete this and get a resistor. Okay, we don't want codes. We want a resistor. Okay, we got a resistor. Now we'll connect this resistor right over here and let it be 1 kilo ohm. That is very perfect, I believe. And now this point will be connected to 5 volt. Now you can connect this to the positive part or negative part, that is your choice. But basically, if you connect to the positive part, it will give you better means way also means better output. Okay. So if we start the simulation now you can see we have omitted the error that was coming, and the LED is glowing. Okay, you can see now the LED is glowing. So see, we have connected our Arduino with an LED successfully. Right. Now what we're gonna do, Arduino is not for connecting with ground and VCC. Arduino is used for connecting things that we could program. Right. So we're gonna delete this connection. We're gonna delete the and we're gonna take this to somewhere of the digital point. So we are taking two. As I told, 0 and 1 are special purpose points used for transmitter and receiving for a purpose. So we will try to ignore these two, and I'm just using the point 2, digital pin 2. Okay, so for programming this, what we're going to do, we're going to open Arduino IDE. I hope you got the link of Arduino IDE in your mail IDs. So just go and access the link and download it and install it. Okay, so I will just allow the access. Now this is the interface that we got. Now, as I told you over here, void setup means the code that we're going to write once, and void loop means the code that we're going to, the actual code, which is going to repeat again and again. Okay, so while writing this code of LED blinking, for example, what we're going to do, uh, this is an LED. Okay, so first of all, the LED should glow, and then after few seconds the LED should switch off. Then after few seconds the LED should glow again. Okay, then after few seconds the LED should switch off. So what is the pattern? You need to know the pattern first of all. Now the pattern is the LED is glowing. After few seconds the LED is off. Then after few seconds the LED is glowing. Right. So till here we get a single pattern: glow, after, or off, after, then again glow. So this is the pattern that we're gonna draw right over here. So let us start. So the first of all you need to understand the digital pins right over here. I will just show you once again. The digital pins right over here has two types of modes. Now what are the modes? The modes are, there are two pin modes. Number one mode is input, and the second mode is output. Okay, the first mode is input, the second mode is output. So there are two pin modes, one is input, one is output. Now what we're gonna do, what we have to do, you just need to understand. Okay, so what is our thing, that what we're gonna do, if you just understand when we use output and when we use input. So when we want the data from the board, okay, for example, you just assume that you are the LED and what you want to glow. If you want to glow, what you need the data from the board. So when you need data from the board, or else the board is giving data to the object, then it is an output. Okay, now on the other hand, if you accept data, if the board accepts data from the object, for example, I am some object and I am giving data to the board, and the board is accepting the data, then it is an input. So did you understand this concept? Just let me know in the comment section. Just let me know in the comment section if you have understood this concept. I repeat again, when the board gives data to the object, it is an output. When the board accepts data from the object, it is an input. Just let me know if you understood this concept, because this is a very important concept. Okay, very good. Now what we're going to do, we're going to go for the coding again, and now you just let me know that pin mode. Okay, Now, when we're talking about pin mode, now how many times you're going to select a mode means how many times you're going to tell the board that this pin is output and this pin is input. How many times we're going to tell? Obviously, we're going to tell once, right? So we're going to write this in void setup because we're going to tell that it is an output or input to the board only once, right? So we'll just write it down, pin mode. Now just go through this syntax because this is case sensitive. Okay, PIN is small, M is capital, OD is small, pin mode. Okay, now pin mode we're gonna write like which pin we're gonna take. We have taken the pin number 2. So now we're gonna write 2 comma input or output. Now what we're gonna do in this purpose is we are giving data to the LED, right? So if we are bored and we are giving data to something, then it is an output. Okay, so we're gonna write output. So when you write the syntax properly, it changes the color. You can see the predefined functions color will get changed automatically. But the user defined function, like if we are writing 2, like 2 we have defined, it is not a predefined function, right? Anything, any variable that we are taking. So those colors won't change in Arduino IDE. Okay, the color of the predefined functions will change. For example, if we don't follow the syntax and we write small m over here, you can see the color has not changed. That means we have made some mistake in the syntax. So now when we write uh, m over there capital, so you can see the color has changed. So we have done properly. Okay, now we have done this pin mode 2 comma output. Now our next thing is we have made the pin output mode, and now our first thing that we're gonna do, we're gonna make your LED glow. So for glowing LED, we write digital write. Now why we write digital over here? Okay, there's a spelling mistake. Yeah. So why we gonna write digital over here? Because we are using digital pin. If we will use analog pin, then we will write analog write. Okay. Now similarly, why write? Because we are giving data to the object from the board. So we are giving data. So we are writing on it, right? So we are using write. If we will accept the data from the digital pin, then we're gonna use read. We're gonna write digital read. If you're accepting data from the analog sensors, then we will write analog read. If you are giving data to something through the analog pin, then we will write analog write. Did you understood this concept? Just let me know in the comment box. So we'll write digital write the pin number 2 comma, and now what we're gonna do, we're gonna glow it. So for glowing it, we have 2 pins. Again, on the first day I explained you, if we use high, low, anything, that gives you 5 volt. So we're gonna write high. So high symbols that we are giving 5 volt, passing 5 volt to this LED. Okay, then after some time, so giving this time gap, or giving this time gap over here, we have the delay function. So delay, okay, so delay, and now we'll write 1000. Now this delay function works in milliseconds. So if we pass 1000 over here, that means 1000 milliseconds. So 1000 milliseconds symbolizes 1 second. So if we write 2000 over here, that gives you 2-second delay. Okay, so we'll give you a delay of 1 second, and then we'll write digital. Okay, digital write once again, and we'll write 2 comma low. Now why low? Because low symbolizes that we are passing 0 volt, or else we are switching off the LED. Okay. Now we'll just use a delay. We'll just use a delay over here of 1 second, and that's it. So if we execute this code, we'll just copy this code and we'll just paste it right over here in the code section. So we'll go to codes, we'll go to text, continue. I'll just erase the drawings. Now we'll just eliminate the code that is already written, paste our new code. So what we have done, we have set the pin mode to output, and then we are switching on the LED. Then after 1 second, we are switching off the LED, and then after 1 second, then the loop goes up, and again we are switching on the LED. If we don't give this line, then LED will switch on. Then after 1 second, it will switch off, and immediately it will switch on. So you won't get a proper orientation. If you're going to run this, you will find that the LED is always on. Actually it is switching off. You can see, you are finding that the LED is always on, but it is switching off. But the thing is, we couldn't see because it is so fast that our eyes, with the naked eyes, we can't see this. So we'll just stop this and we'll just write the delay once again, and we'll just start the simulation. Now you will see that after every 1 second, the LED goes off and on, off and on. So is this code concept clear to you? Just let me know in the comment section. We'll just stop the simulation and wait for your answer. Okay, let's proceed further with the further concept. Now we have understood the basic of LED programming. Now, as per previous session, you must have known the if-else concept. So to understand the if-else concept over here, we'll just try to do the same thing with if-else. So we'll just come to the Arduino. We'll just eliminate this. The mode will be same. And now we'll write, let us take a variable. Let us take int a equals to, or you can say choice equals to 1. Okay, now we're gonna write the if else if choice double equals to 1. Now why double equals to? Double equals to is used for checking, and single equals to used for assignment. Now if you write single equal to over here, now what will happen? The value of choice will become 1. Okay, we'll just terminate it because every line needs to be terminated. Just need to understand this. Now if you write choice equals to 1, that means we are assigning the value of choice equals to 1. But if you are writing double equals to 1, now this resembles that what we are doing, we are checking if value of choice is equals to 1. Okay, so we'll just go for it. Now it will inside this, if choice equals to 1, what we're gonna do, we're gonna glow the LED. Okay, so we're gonna write digital okay, so digital right, and over here we're gonna pass 2 comma high. Now we'll just use the syntax properly. Now this is this over here, digital right 2 comma high. Now what we have done, if the choice is 1, we're gonna glow the LED. Okay, or else we can do much better. We can do that, we're gonna blink the LED. If the choice is 1, we're gonna blink the LED. So let's write delay 1000, and then we'll write digital write 2 comma low, and then similarly delay 1000. Okay, so now what we have done, if the choice is 1, we're gonna blink the LED. Else, excuse me, now else, in else what we're gonna do, this if this choice is not correct, okay, if this choice is not correct, then this block will get executed. Okay, so if choice is not equals to 1, then what we're gonna do, we're gonna just glow the LED directly. So we'll write digital write, we'll just take this digital write, and we're gonna write 2 comma high. That's it. So what we have done, let's understand the code once again. We have used if and else concept in the practical orientation. What we have done, if choice, now choice is a variable right over here declared. Now it is an integer type, and if this we have assigned the value by default 1. Okay, now what we are doing, we are understanding that if choice is equals to 1, we're checking, then this block will execute, and which resembles that we are just blinking the LED. And now if choice is not equals to 1, then what happens, we will just glow the LED directly. It will not blink. Okay, we'll just copy this entire code, and similarly we'll just go for over here and paste it right over here. So we have pasted our codes. Now we'll just start simulation. Now let's see, we have by default choice equals to 1, so LED is glowing. Okay, now we'll stop it once and now make the choice maybe 10, and now we are just starting the simulation, and now you can see it is not glowing, it is constant because it is executing this block, else block, right? It is executing the else block, so it is constant. And if we are making this 1 again, then again it will be executing this block, which resembles that it will blink. Are you getting me? So these statements are working. Now there is one more way of testing some of the things. Now this way is serial monitor. Now what is serial monitor actually? If we want to write anything or comment any of the things, then we can get those comments over here. Okay, for example, to begin this serial monitor, to begin this serial monitor, we write serial capital S serial dot begin. Okay, now the baud rate, now over here we are using the baud rate 9600. Now what is the baud rate? This is the speed through which data is transmitted from the board to the monitor. Okay, now again I am repeating, this is the speed through which the data gets transmitted from the board to the monitor. Now we are beginning this serial monitor. Now to print on this or to write on this, we're going to use, for example, if this block is executed, then we can write serial dot print. Now we can use two things over here. One is print and one is print ln. Now what is the difference between print and print ln? You just understand. When we write print, then the data will be printed side by side this, like this, side by side the data gets printed. Okay. Now, and when we write print ln, then the data gets printed line by line. Print line, print line. Okay. So it gives an means next line. It takes the cursor to the next line on every print or after every print option gets executed. Okay, so I hope you understood this. Now we'll just go for this serial.print ln. We're going to use ln over here. Serial.print ln, and if block executed, if you're going to write in double quotes, if block executed. Okay, now we're going to close the double quotes, we're going to close the braces, and we're going to terminate this. So this is a syntax for writing a comment in the serial monitor. Now similarly, we're going to copy this and just paste it over here. Now we're going to write it down like else block is executed. Okay, so what we have done, we have to check it. If we don't have a objects with us, like we don't have an led, we don't have any of the equipments with us, so we can check directly through the serial monitor that our code is working properly or not. So we're going to start the simulation, and you're going to see if the choice is 1. If the choice is 1, then if block will get executed, and you can see if block gets executed. Okay, if block gets executed. Now if we change the number like 10, and if we execute this, then you're going to see from now onwards else block will get executed. You can see else block is getting executed again and again. So this is how we're going to check serial monitor. Now, as I told you, there are always two options. One is to write or print on the board, and other is to read from the board. Now, over here, we are giving choices by default. Okay. But what else if we want to accept the choices from the user? So for accepting the choice from the user, we're going to write in choice. Okay. And we're going to use this serial monitor to enter our choice. Now to read this, there is a syntax that you want to understand. We're going to write if serial dot available. Okay. Now what will this do? This will let us know that if there is anything available in the serial monitor, serial dot available greater than 0 means if there is anything available in the serial monitor, then what we're gonna do, we're gonna read the data. Now where we're gonna read the data? We're gonna read and store it in choice. So we'll just use choice equals to serial dot read. Okay, we're gonna terminate. Now what we have done, if there is anything coming from the serial monitor, then this line will check. If there is something, then it will go inside, read the data, and store it into choice. I repeat, it will read the data and store it into choice. Now whatever is the output, it will check accordingly and give us the final data. Okay, so we'll just go forward. Now we'll just execute this code. Okay, so there is an issue, I believe. I've written wrong serial. Okay, over here. Here S should be capital. Now we'll just start simulation, and the simulation is done. So by default, you can see they're ultimately giving you the else block as the data from the serial means the choice has the by default value nothing. Okay, so that means it is not 1. Then other than 1, whatever it is giving us executing the else block continuously, because else block is totally dependent on the loop. It's getting continuously called, and we are continuously writing the else block. Now if we pass on the data 1, now when we are passing data, okay, we haven't got the data 1. We need to check a little bit of the thing. So first of all, we'll just comment this part. Okay, I need to delete this part first of all, then we'll again write it down, not an issue. So we are just, what we're doing, we are just writing serial.read and we're terminating this. So let us see what we're getting from the choice. So we'll just print the choice first of all. Serial dot print choice. Okay, so we are just printing the choice. Let's see what we are getting. So we'll just execute this, start the simulation, we'll clear the serial monitor. Okay, so if you're writing 1, we are getting 49. Okay, so this is the reason that why we were when we were writing something, it was not executing as our choice. So why we are getting these things? Because whatever value we are putting, it's giving us a character value over here. Means when we are giving a character value, and now it is changing the character. Means one, it is taking as a character, and when it is changing the character into integer, it is giving the ASCII value to us. Okay, so what we need to do, we need to change this int to character type. Okay, we're gonna change this int to character type. Okay, so we are changing this into char choice, and now we're gonna use this choice, and now we'll just execute this. So now you will find that we are getting the exactly the same data that we wanted. Like 1, so we are getting 1. We'll clear it once again, and now 2, we are getting 2. We are getting, if we are writing 10, we are getting 10. So you can see we are getting a character out of it. Okay, so now what we will do, we will just uh, we will just write those codes once again. So we have already written it, so we'll just copy this once again and paste it over here. Okay, so little syntax issues, we'll just rectify those. Okay, now it's better. So now we'll write one more block like serial.print. Now print ln, and we'll write it over here like if block executed. Okay, in double quotes. Similarly, we'll just copy this and paste it over here for writing else block is executed. Okay, so we are done. So now what is our thing is totally, we have defined choice right over here, and what we're going to do, we're going to read the data from the serial. If anything is coming, when anything is coming, we're going to write the choice, we're going to read it, and we're going to assign it to the choice variable. Okay, so once the choice is assigned, choice will act according to the if else block that we have written over here. So we're gonna write like if we execute this, so we are just running the codes. We have done the simulation. Now continuously it is doing else block, and if we write 1, okay, if we write over here 1 and then press enter, okay, it's not okay. Okay, now one more mistake that we have done, you can see properly that we have assigned this to character type, right? Now when we are assigning this to character type, we need to check it also as a character. So for checking it also as a character, we need to use single quotes or double quotes over here. There is no difference between any of those for this particular thing. So when we are checking it that one is a character that is same as choice, then only we will get the proper output. So if we write 1 now, then you will find that if block is getting executed. You can see now if block is getting executed. And if you write any other numbers other than if, then again else block will get executed. Now again I'm stopping simulation, I'm clearing it. Now there is an issue in this code. The issue is when we're executing, continuously else block gets executed. So why is this happening actually? This is happening because if there is a data or there is no data, this block is getting executed continuously, because what loop does, loop is continuously running. It doesn't stop. It always checks and runs, checks and runs. So what happens over here, this block is continuously running. So for eliminating this block from running continuously, what we could do, we could write this two blocks inside this statement. So what happens, when the serial data is available, only then it will execute. This blocks will get executed, check and executed, and then it will stop. Okay, for once. Now let us see what is happening. So we just starting, we'll just clear it. So there is nothing. There is nothing that is coming now. Okay. Now if you write one, then the data is there, and if block gets executed after every 1 second, okay, and then if we write again 10, then accordingly else block gets executed. Okay, so this is how we're gonna use this. There are some other glitches over here, so it's your task to rectify the glitches, what actually the glitch is, and rectify it. If you have understood the concept of these codes, you will rectify it very soon. Right, I hope you understood till over here. Now if we go for the concept of for loop, now we'll come back to the Arduino IDE. Now, what is the concept of for loop is? For loop is just like the void loop over here. But the thing is, if we require more number of loopings, then we use for loop. Okay. So let us write a code like what we should write. Like we can do one more thing. We could write a code something like this. Like we're gonna take one more LED. Okay, we're gonna take one more LED right over here. Let color be yellow, and now we'll use the same ground, and the anode maybe 3, digital pin 3. Now what is our next? Okay, let us join a resistor. So we'll just take a resistor. Okay, so we got a resistor. We just connect this. We'll just connect this block right over here. Okay, so we have connected a resistor. We have two LEDs. Now our task for using for loop is, first of all, for 5 times, this LED will blink. Okay, I just highlight it. This LED will blink for the first 5 times, and for the next 5 times, this LED will blink. Okay, so what we are doing, for the first 5 times, this LED will blink, and for the next 5 times, this LED will blink, and this process gets continued. Okay, so for this kind of thing, we cannot use only void loop for writing these codes. Okay, so for this purpose, we not need to use some other loops inside the void loop to execute several looping functions inside the loop. Okay, so we will be using for loop for this particular case. So how are we going to use it? So let's move to the IDE, and let us delete this whole thing. Okay, now for using a for loop, the syntax is for I equals to 0. Now what is this I? I is used as a counter. Okay, so we're gonna initialize this I. So we are not using choice, we are using I. So we will initialize the I as an integer type. The format is I. So now we'll count 1. So we'll start the I from 1. We need 5 times. So I less than equals to 5. Okay. So I will start from 1 and end when it will reach to 5. And what we need, that every time value of I should increase by 1. So we're going to do I plus plus. So what happens? So initializing the I with 1. Now every time I get executed, After that, it will initialize by 1. I plus plus means I equals to I plus 1. Okay. So I plus 1 means first of all the value is 1, then again it will cut and get the value 2, then next the value will be 3, next the value will 4, the next to the value will 5. And when it reaches 5, when it the value becomes 6, it will execute out of the loop. Okay. It will get out of the loop and there will be no other execution. So over here, inside this loop, what we're gonna write? We're gonna write digital. Okay. So we're gonna write digital write, and inside it we're gonna write 2 comma high. Okay. So we're gonna write 2 comma high, and then there will be a delay because we are using means first of all there will be the first LED that will glow means blink. So delay 1000. Similarly, we'll just write digital write 2 comma low, and the delay will be again 1000. So this is for the first loop for 5 times. The first LED will glow. Similarly, we'll copy this and paste it over here. For the next 5 times, the second LED will glow. So we'll write the 3 over here. 3. Okay, so now the digital pin 3 will be high and low for the next 5 times. For the first 5 times, digital pin 2 will be high and low. Okay, so now you need to know one more thing. So we are using 3 over here, but we haven't initialized the pin mode over here. So we'll just initialize it. So initialize 3 with this thing. Okay, now one more thing you need to understand, that the digital pins may be by default, means according to your previous codes, it may be that the digital pin 2 may be by default high or by default low. Okay, so to get a proper output, and what actually these things happens, or these things bothers you when you're using pattern type of codes. You're making LED patterns. So these type of codes will bother you, these things. So now for avoiding these things, what we need to do, we need to initialize the data. So we are just initializing the data, and how we will initialize? At the setup part, means when we are writing the code once, okay, at the setup part we'll write the by default data that we wanted, and we want the by default data for each every pin should be low. So we'll just write it down, digital write, digital write. Okay, 2 comma low, and similarly we're gonna write a digital write 3 comma low. Now what happens? By default we have set the digital pin 2 and digital pin 3 to be off or low. Okay, so what happens? It will give us a smooth data. So you can understand the steps or the structure of Arduino code, and the steps are pin mode initialization. Okay, pin mode initialization. Now the second step is uh, pin declaration. Okay, pin declaration. Now what is pin declaration? Input your high or low. Pin mode initialization, pin declaration, and the last step is to write the code. Write code. Okay. So pin initialization, pin declaration, and writing the code. These are the 3 steps that you need to understand and follow. Okay. So now we have written this code properly. Now what is this code resembling? That the first 5 times the LED 1 should glow, and the second 5 times the LED 2 should glow. So we're gonna just copy this entire thing, and we'll just paste it in the code part. Just select everything right over here and we'll just paste this and we'll start the simulation. We'll clear the serial monitor. So now you can see 1, 2, you can see over here, 3, 4, 5. Now 5 times it has grown, now this will grow. 1, 2, 3, 4, 5. Okay, so now again it will switch. So it is a pattern that is continuously growing. Okay, one by one, it is continuously growing, and this is how the thing goes on. So we'll just stop the simulation. So we have understood the practical implementation of Arduino board. We have understood the practical implementation of the if-else concept, and we have understood the practical implementation of the for loop. So if you have any doubt, just let me know in the comment section for today's session. Okay. If you have any doubts, just let me know in the comment section.